Importance of algorithms. Problem solving. Algorithms provide systematic and structured approaches to problem solving, allowing for efficient and effective solutions. Efficiency. Well designed algorithms optimize resource usage, leading to faster execution times, reduced energy consumption, and improved overall system performance. Reproducibility. Algorithms enable the replication of solutions across different platforms and programming languages, fostering collaborations and standardization. Automation. Algorithms automate processes, enabling system to perform tasks, analyze data, and make decisions without continuous human intervention. Data processing. Algorithms are fundamental for data processing, including sorting, searching, filtering, and transforming data, facilitating meaningful insights from larger data sets. Computational complexity. Understanding computational complexity helps in selecting appropriate algorithms, balancing time and space efficiency for different problem scenarios. Scientific advancements. Algorithms are vital for scientific research, aiding in solving complex equations, simulating physical processes, and conducting experiments in silico. Artificial intelligence and machine learning. Algorithms form the backbone of artificial intelligence and machine learning, powering tasks like pattern recognition, classification, regression, and optimization for data driven decision making. Communication and networking. Algorithms are crucial in designing efficient communication protocols and network routing strategies, ensuring reliable data transfer between devices. Cryptography and security. Algorithms underpin secure communication through encryption and hashing, safeguarding data confidentiality and integrity. Optimization problems. Algorithms are employed to find optimal solutions in various domains, such as resource allocation, scheduling, and logistics, improving decision making processes. Innovation and technology advancements. The development of new algorithms often leads to technological breakthroughs, driving progress in fields from computer graphics to computational biology. Now let's discuss issues with algorithms. Algorithmic bias and fairness. Algorithms can perpetuate biases present in training data, leading to discriminatory outcomes, especially in machine learning applications. Transparency and explainability. Some complex algorithms lack transparency, making it challenging to understand and explain their decisions, raising concerns about accountability and trust. Data quality and integrity. Algorithms heavily depend on the quality and integrity of data. Inaccurate or biased data can lead to the flawed outcomes. Overfitting and generalization. Overfitting occurs when algorithms are too closely tailored to training data, negatively impacting performance on new unseen data. Computational complexity. High computational complexity in some algorithms can make them resource intensive and impractical for certain applications. Security concerns. Algorithms may be vulnerable to attacks such as adversarial attacks in machine learning or vulnerabilities in cryptographic algorithms. Ethical considerations. Ethical issues may arise when algorithms are used in decision making processes, leading to concerns about privacy, consent, and fairness. User acceptance and bias. Algorithms may not always align with human values, leading to resistance and lack of acceptance. Biases in training data can be amplified, reinforcing stereotypes. Environmental impact. Resource intensive algorithms, particularly in deep learning, can contribute to significant energy consumption, raising environmental concerns. Regulatory and legal challenges. The rapid advancement of technology has outpaced the development of regulatory frameworks, leading to uncertainties in legal and ethical consideration. Addressing these issues requires interdisciplinary collaboration, ethical consideration, and ongoing efforts to ensure that algorithms are designed and deployed responsibly and with social societal well being in mind.